Kia ora. So we're going to look at how to tell whether two events are statistically independent. And that's a question they can often ask in your exam for probability concepts. So what are independent events? They're events that have no effect on each other. So an example of that would be whether it's raining here in Christchurch and whether it's raining in London. Another example of independent events is when you flip a coin and then you roll a dice. What happens on the coin and what happens on the dice are independent because they have no effect on each other. So the opposite to that is what we call dependent events or non-independent. And they're events that do affect each other. An example of dependent events would be whether you're from Auckland and then whether you're on time to school in the morning. Why would they be dependent? They're dependent because if you're from Auckland, you're more likely to be on time to school because everyone leaves at once. So independent and dependent. So we're going to start by looking at the mathematics that you might have to do to show whether events are independent. So let's look at the coin and the dice example. So getting heads and rolling a 6 are independent events because neither of them affects the other one. And if we look at a tree diagram, we can show that mathematically because we know there's a 50% chance of getting heads. Chance that you roll a 6, if it's a fair 6-faced die, will be 1 in 6. And the chance that you don't will be 5 in 6. What's important is that that doesn't change if you got tails on the coin. Still 1 in 6 and 5 in 6. So a really easy way that you can show mathematically that these two events are independent is that the two numbers here are the same. Okay, and remember this is the probability that you get a 6. Given that you've got heads, this is the probability that you get a 6, given that you've got tails, and they are the same. So, spelling that out, down the bottom here, probability of getting a 6, we know that's 1 in 6 chance. Whoops. And that's the same as the probability of getting a 6 if you got heads and if you got tails. All three are the same. And it turns out if you can show two of these three things are the same, you've proven that they're statistically independent. Okay? Now, if you look at another way you can also show it, which we'll come back to later, is if you multiply the probability of each of the events, you should get the probability of them both happening. And in this case, probability you get heads times probability you get a 6 is going to give you the probability, of getting heads and a 6. And you can see that because if we multiply along the branches here, we get 0.5 times 1 in 6, and you can see that's going to be the same thing. So probability heads and 6 is going to be 0.0833. Okay, so let's look at a situation where they're not independent, or we can say they're dependent. And this is the example of being from Auckland and being on time to school. So they are dependent or not independent. So how do we show that mathematically? Well, let's look at an example. If we know that 10% of CGHS students are at Auckland, so that's 0.1, that means 0.9 aren't. And we're told that last week, 89% of CGHS students were on time, which we're going to call T. So we would write that down here as 0.89. Breaking this down by Auckland and non-Auckland, so we're told that 95% of Auckland students were on time. So this is going to be 0.95 here. compared to only 79.5% of non-Ackland students. So this is going to be 0.795. So notice how these numbers are different, and that is a way of proving that being from Ackland and being on time are not independent. They're linked. So if we use the notation for that, this is the probability of being on time given that you're from Ackland. So that's going to be 0.95. This is the probability of being on time if you're not from Ackland. So that's going to be 0.795. Because these are not the same, we know that the events being from Ackland and being on time are not independent, or they're dependent. Okay, so easy way to tell whether two events are independent or dependent is by comparing the probabilities on the equivalent branches and seeing if they're the same or different. So just a summary at the bottom, and this is the part you sort of have to memorize. There are two formulas you can use to test in the exam whether two events are independent or not. And we're going to write them at the bottom. For any two events, A and B are independent statistically. Statistically independent if and only if the probability that A happens is equal to the probability that A happens if B has happened. So that's one of the ways you can test. And what that's saying is that the probabilities will be also, it means the probabilities will be the same on the equivalent branches of the tree diagram. The other way you can also test whether they're independent, which is sometimes easier, is if you multiply the probability of each event, so probability of A times probability of B, and you get the probability of A and B both happening, then it means they're independent. Now the opposite is true as well. If either of these statements is false, then it means that they're not independent. And so I'm going to write that at the bottom. If not, so if either of these statements I've put here is not true, then A and B are dependent or not independent. Dependent, which we also call not independent. What we want to do now is practice some examples, and that's where it will start to make a bit more sense. So if you go to page 59 of your workbook, there's some notes and examples, but if you go to page 61, there's some questions on page 61 that we're going to do. And I'll just zoom out a bit so you can see the whole sheet. So go to page 61.